Okay, so the Pythagorean theorem. We started using this last week, and today we're going to do a more thorough lesson on the Pythagorean theorem. This is a very ancient formula, very ancient. And more than likely, it popped up in different parts of the world independently because humans created numbers to count and measure the world, right? That's how we're able to do the many things we're able to do, unlike any other species. We created the number systems, and we use it to manipulate and organize our world. We use numbers to measure the sides of shapes, and shapes are also very important to humans, right? Everywhere you look, you see rectangles, like your door. Every single day you open that door, it's a rectangle. A lot of windows, right, are squares. Squares show up in construction and when you're building houses. Right triangles are important for the same reason, right? And a lot of times a right triangle is used to make sure you have a right angle. So being able to know the relationship of the three sides of a right triangle became important, and that's what this formula means. This formula is always true if you have a right triangle. The relationship of the three sides is always c squared, the largest side, the hypotenuse, is equal to the sum of the squares of the legs. Okay, and ancient Samaria, which is where Iraq is now, these two rivers, the Tigris and Euphrates, up in eastern Turkey, these rivers came down off the mountains and started flowing this way with all the water, right? And so this area of the world was one of the first places that humans started to settle and grow agriculture, was because of the availability of these waters. Well, they found, this is like 3000 BC, like 5,000 years ago. They found these clay tablets when they did this archaeological dig. And look at what's on those clay tablets. That's a square with diagonals here too. Now those little symbols you see, that's Sumerian number systems. The calculation that they did, we're not quite sure, but we see that they knew how to do this. And what those symbols represent? Okay, well, let's do the math. And okay, and before I do that, also in ancient China, there's some scrolls where we see this diagram, which indicates they knew the relationship between right triangles and a square. Okay, well, let's solve this ancient Sumerian problem. We're going to have a square, and we're going to find the diagonals of the square. Okay? So this was important to them, otherwise they wouldn't have done this, right? So here's the diagonal of that square. Well, let's go ahead and make the sides of the square 1. Okay, so we're looking for the C, the diagonal. This is going to be a right triangle. Okay, so c squared equals 1 squared plus 1 squared. All right, so then c squared equals 1 plus 1. That's not 2 times 1. Okay, 1 squared means 1 times 1. All right, that's 2. Okay, so we need to find the square root of 2. Okay, so let's go to our Google calculator, and I'll go ahead and clear this. And again, sometimes if you're doing a calculator, you push 2 and then you push the square root button. Some calculators, you push the square root button and they give you parentheses and you put the number in there. Okay, so 1.414, and I'll just leave it to 4 decimal places too. So that's what the C is. That's what the diagonal of the square is when the units of the sides are both 1. So how is this important? Well, finding the diagonals in agriculture and in construction is very important. What we just found out is the diagonal is always 1.4142 times bigger, right? So if you had instead a square that was 10 times bigger, well, the diagonal is always 1.4142 times bigger than the side of the square. So that means the diagonal is 14.142. All right, that's why the Sumerians solved that problem, because they needed to know for the diagonal of a square, how many times bigger is it than the sides? And once they figured it out, then they could actually use it in practical reasons, because finding the diagonal of a square in construction is extremely important. And, we're talking about 3000 BC, so they didn't have electricity back then, right? They didn't have gas-powered engines. They had to do everything by hand.